Hi everyone, this is Miss S from Excelsior Charter School, and today we're going to be covering Geometry, Lessons 9-1 and 9-2 on translations and reflections. We have quite a lot of vocabulary and important information to go through today, so go ahead and get your notes ready to put all this information in. Alright, we're going to start with transformations. Transformations of a geometric figure are just a change in its position, size, or shape. So here are some examples of transformations. You can have a figure slide, you can have a figure flip over, you can have a figure turn around a point, or you can have a figure blow up and get bigger, or shrink down and get smaller. Those are all different types of transformations in geometry. Isometry is transformations in which the figures remain congruent. They are also known as rigid motions. So isometries are slides, turns, and flips. They are not ever the ones that get bigger or smaller. Here are some examples of isometries. So when the figures flip, like you see in the first puzzle piece here, the red, that's known as a reflection. When a figure slides, it holds its same position and spatial awareness. It just moves along a plane. That's called a translation. And when a figure turns about a point, that's known as a rotation. All right, pre-image versus image. So when you have different transformations, the original figure is called the pre-image, and then the resultant figure after you've done some sort of transformation is called the image. So in the figure here, in the picture, the blue is the pre-image where we started with the triangle, and then we reflected it, we flipped it over, and it became the red image. Some transformation symbols and notations, some things that you're going to see as we go along here. A different transformation here, they map the pre-image onto the image. And we use arrow notation to describe transformations, and we use primes, which are little apostrophes, to use to label the image. So our pre-image here was triangle ABC, and you can see this arrow here. It gets mapped onto triangle A prime, B prime, C prime. That's how you read that. So the pre-image gets mapped onto the image. Triangle ABC gets mapped onto triangle A prime, B prime, and C prime. Now, translations are slides. It maps all the different points of a figure the same distance in the same direction. And so you can see the K hasn't flipped around, it hasn't turned, it's still a K in the pre-image and in the image. All it did was move positions. And what you might see in the notation for this is something like this. X plus 5, comma, y minus 6, because the slide moves that K 5 spots to the right and 6 spots down. So X plus 5, 5 spots to the right, 6 spots down, 6 spots down. A reflection is a flip. So we're going to take an image and flip it over. And so we begin on the right-hand side with the pre-image, and it gets flipped over. Usually it's a line that it gets flipped over, and that line is called the line of reflection. And so you can see that one here, that happens to be the y-axis in this case, and it just gets flipped over, and you can map this pretty simply by using the distance between. So from here to here was 2 spots, and so as you'll notice from here to here is also 2, and then from here to here was 4, so from here to here is also 4. And then from here to here was 5, which means from here to here also has to be 5. And that's how they flip over this line. Reflections are kind of mirror images of each other. They have opposite orientations. They appear to maybe be backwards. The line of reflection does not have to be an axis, although it frequently is. It could be an x-axis, it could be a y-axis. It could be any line that you can put into a coordinate plane. So it doesn't have to be horizontal or vertical either. It could be side to side as well. And then our last term today, a composition of transformations, just means that it's more than one in a single time, a combination of 2 or more. So in this particular image here, we have this pentagon, and it starts over here on the right with the pre-image, and then it translates, it slides over here to the left, and then it flips, it reflects over the axis here to become the actual image. So this second image here isn't one that you would normally see. You would normally go from the pre-image straight to the image. But to show you the composition of those transformations, it included a slide, which is a translation, and a reflection or a flip to get to the image. So now let's do a couple problems from your homework. This says the figure below is an isometry. Remember that an isometry is a transformation in which the pre-image and the image are congruent. So this pre-image is quite a bit larger than the image. So this would be false. This is not an isometry, as they are not congruent. Our next question here says the translation x, y maps onto x plus 1, y minus 1 in the image from the red figure to the blue figure. So the red is the pre-image, and it wants us to move x plus 1. So if we pick any of these points here, we want to move it over one spot, and that's x plus 1. And then y minus 1 means we want to move it down 1 from there. So to the right 1 and down 1, to the right 1 and down 1, to the right 1 and down 1. All three of our vertices move to the right 1 and down 1, so this is a true statement. And our last one today, use the image below to answer this question. The coordinates of point R reflected across y equals -1 would be -1, -4. So to begin with, let's find point R here. Here it is right here. And then the line that we were reflecting it across, our line of reflection, is y equals -1. So let's put that in as well. So there's that line there in yellow. And then to reflect it across, what we would do is count from our red dot down to our line. We'd have to move 1, 2, 3 spots down. So we would have to move 3 more spots down, 1, 2, 3, to reflect it across. And that point is, in fact, -1, -4. So this is a true statement. Good luck, everybody. I hope you guys all do great.